my commentary on my wife's cooking did not go over well. So, graph the path of a projectile given by the parametric equation. When does the projectile hit the ground, and what is the shape of the trajectory? So we're not really looking at anything too calculus-y here, because they're not asking for anything related to the speed, but we could easily find that. It's just a matter of finding the derivative. So I would imagine that it's not the kind of thing that you want to do by hand too often, although it's 20t. These numbers multiplied by 20, they're not going to be terribly crazy. It's a linear relationship. So 0 times 20 is 0, then 10, 20, 30, all right, so we'll take that. That's easy enough. Now, in terms of the y, well, we know we're going to start off with 64 at time t equals 0. Then you're going to subtract 16 for the 1 second, and if you want to backfill the 0.5s, you can. That's, again, assuming you want to do it by hand. I'm not really sure under what circumstances that would be true, but yeah, you may only need the calculations for the y stuff, but it's not going to understand what you're talking about unless you put your x equation and your y equation in. So even though we no longer need the x equation, because we already did that work, why hitting a t brings up a 4 is beyond me, but whatever. Like a dying giraffe out there. So you go to your table and you get this display. Now, some of us are more familiar with the calculator than others for reasons that I just kind of went through. You don't see the 0.5s. So hopefully we all know that table setting is the way to go. The 84s, they give you this option when you go into the table. It says press plus for change in table. So you can change it to whatever you want, in this case 0.5. Allows you to go by 0.5s, which is good news. If you have a calculator that does not show you that, then you would hit second window. It'll bring you into your table setup. Honestly, I don't need half the stuff that came up in that table. Why did they do that? I need to go from 0 to 3. So I would start it at 0 and still go by 0.5. Again, I think I mentioned this, maybe I didn't. In your table setup, always on auto. Never a reason for it to be on ask. If somebody tells you to put it on ask, it's because they don't know anything about the calculator. All right. So, for the love of Christmas, I just want it to stay the same size when I'm moving it. All right. So, you get your values from here. Easy enough. But then you can see your scale is going to be dependent on some significantly small values. So 60, 48, 28, 0. And then negative 36, negative 80. Okay. So if you're dealing with approximations, when does the projectile hit the ground? Somewhere between 2 and 2.5 seconds. Assuming this is seconds, by the way, it's time. Any units of measure would be reasonable. So it's going from 0. Oh, sorry, it's at 0. Go. Yeah, I thought it was a positive number. I was like losing my mind for a second. Yeah, so it's at 2 seconds. So you don't even need to solve an equation. If you needed to, of course, you would set your y equation equal to 0 and solve for the value of t. But this seems to be tailor-made for exactly what we need it for, so that's good news. We just need a scale to set this up. 1, 2, 3, 4, 5, 6. So we'll go by 16s. You don't have to label them all, obviously. But, you know, now that I said that, of course, I'm going to proceed to label them all. 16. By tens, I think, for the x. 6. All right, so 0, 64, 10, 60, ballparking it, 20, 48. That's a game. 40, 0, because that's a 0. Fun fact. So we have this. All right, it's parametric, so we have to indicate the flow. So arrows. Yeah, you're going to get really aggravated when you lose a half a point for not putting that down. But, sorry. The one thing, so the arrows that follow the projectile even through the ground, even though it doesn't necessarily make sense that that would be the case. It's like, when does the projectile hit the ground? Well, you would think it would just kind of stop right here. But we're really talking about what the path would be if it could continue. So you just follow the progression regardless of what your common sense tells you about the physical constraints.
At some point you had mentioned why we don't put an arrow at the one endpoint as opposed to on the sides. You mentioned that like we put the arrow at the endpoint for something, I forgot.
Oh, because this one has a finite set of endpoints. So point to point. If it were a case where you were given a domain where it said for t values greater than or equal to 0, for example.
So infinity.
Infinity.
Or positive infinity.
Right, exactly. So in that case, you would pop an arrow on the rightmost part of the graph, the one that's going out to infinity.
Okay.
Yeah, it's fine. All right. So when does the projectile hit the ground? We would say after 2 units of time. Projectile will hit the ground. All right. One thing I really couldn't say, and the shape of the trajectory I think is obvious. It's parabolic. But one thing I wouldn't be able to do at this point would be to say something like, what is the velocity of the object when it hits the ground? Because you'd be like, the velocity of what? And I'd say the object. And you say, well, in what capacity? Are we talking about the horizontal velocity, the vertical velocity, the combined velocity? Like, it's not specific. And in fact, the only way I'd be able to ask you anything about the velocity, so the derivative of our position model, would be if I were overly specific about it. I'd have to say find dx dt or dy dt. But I could also ask you to find dy dx, so that's something we're going to work towards. The good thing about the calculator, one of the many good things about the calculator, is that if we create the graph, t is t. Like it's either given to you, or you have to make a kind of a educated guess as to what it could be. The step is just saying the increments of t. So we'll just go by 0.5s, but then that could give us an overly angular picture. So maybe you want some more points. It really doesn't matter as long as you get the general shape. So we learned that last time that if you ended up with something that was too angular, that you just drop the t step value down. So if I put in 0.5 to correspond with this, it may not give me what I want visually, but it's a place to start, and that's not the worst thing in the world. So 0 to 60 for our x min x max, and then negative 80, really for the scale. I mean, I could go by tens because these are clean, but it really doesn't make a difference. Negative 80 to positive 64. Going by well, I went by 16s on my graph, so I'm just going to put that in there. And then hit graph. And you see, it did it quickly. I mean, it's not overly angular. If I made my t-step smaller than 0.5, it may be slightly more curvy, but nothing too crazy. You know, so this gives us a good sense of what the graph ought to look like. Now, if I wanted to find, because I know the object will hit the ground after 2 seconds, if I wanted to find a velocity, I could go into my calculate menu. You know this from Calc 1, Calc 2. Second trace. It's a much more restricted menu now. You know, previously it would ask you if you wanted to find zeros, maxes, mins, antiderivatives, and so on. The issue in parametrics is because there's so much confusion as to what variables you're working with. The programming is so limited that it doesn't even bother. I'll tell you the value and I'll tell you some derivatives, and that's about it. So a value, that if you know a particular value of t, you can put that in and it'll give you the x and y values for that. That's nice. But you could also get some derivatives. So if I wanted to know the combined velocity, dy dx, after 2 seconds, I can get that piece of information. Now, the interpretation of that is going to be a little bit of a different story, and also, you know, something we're working towards. But you can get numbers. You can get numbers from this, and that's a good thing, you know. So, but like I said, more on that later. All right. So star is gone. All right. So again, stars don't mean very important problems. This will be on the test. It means that that's the problem that we're doing next class. So it goes away now. All right, we did these together? Oh, look at that. Oh, then I can kill that recording then.